Okay, so we're going to talk about the sampling distribution for a difference in means. And today we're going to cover things talking about the shape, center, and spread of a sampling distribution and the difference in means, and talking about the conditions that need to be met to make all this happen and move forward with it. So again, we're going to talk about the shape, center, and spread of sampling distribution for a difference in means, which will be notated as you see there as x1 bar minus x2 bar. Let's start off this initially talking about our shape. So for our shape, we need to have both of the samples meet this. So for this, I'm just going to write that out. Both samples must meet. Okay, so both samples meet. With this, for it to be approximately normal, we will need to know first off about the population and if it is at approximately normal, right? So with that, we need to know if it's approximately normal population. Population is normal, which will be given to you by in the problem. It will be stated by that as far as what needs to be said for population is normal. It will be distributed by that. It will be notated by that status of population is normal, or it'll say normal distribution, something to that standard, something with the word normal involved in it for you to understand the population is normal. The second thing we'll want to know about is our central limit theorem. In other words, if our sample size is greater than or equal to 30, okay? Now, if it is not greater than or equal to 30, if our sample size is not greater than or equal to 30, then we need to have something else checked off on this. So you need to then draw a graph, shall we say, of the data. So that can be as you just do a dot plot, you can do a histogram, you can do a bar chart, something to show the data so you can see that there is no strong skew or outliers. So again, we want to have no strong skew or outliers. And that's what you have to state after you've drawn out a graph of some kind, either a dot plot, like I said, a bar chart, histogram, something that relates to the data that's given to you in the problem. Those have to be checked off for the shape. So now let's look at the center. So we're looking at the center. Again, we would simply say our mu of x bar or x1 bar minus x2 bar is going to be set up to equal the overall mean of the first sample minus the mean of the second. So the population mean of the first sample minus population mean of the second sample. And then we're going to talk about our spread. So for our spread, we're going to need to calculate our standard deviation. So for the spread, we have standard deviation of x1 bar minus x2 bar, so the difference in those means. And now that we're dealing with this, we need to worry about the way we calculate our standard deviation for the means. In which case, you will take the standard deviation of the first sample and square it, divided by sample size of 1. And you're going to add that to the standard deviation of the second sample and divided by the sample size of 2. And that's how you're going to calculate that based on that, dealing with the population standard deviation squared of the first sample over the sample size 1 plus the population standard deviation of the second sample divided by the sample size of number 2. And that's how you're going to calculate the difference, standard deviation of the difference for those samples. So let's go through a little example here from the book and see if it makes a little bit better sense.
Hi, this is Jason Molesky. In this example, we'll take a look at describing the sampling distribution for the difference of means. A fast food restaurant uses an automated filling machine to pour its soft drinks. The machine has different settings for small, medium, and large drink cups. According to the machine's manufacturer, when the large setting is chosen, the amount of liquid, we'll say L, dispensed by the machine follows a normal distribution with mean 27 ounces and a standard deviation of 0.8 ounces. When the medium setting is chosen, the amount of liquid M dispensed follows a normal distribution with mean 17 ounces and standard deviation 0.5 ounces. To test the manufacturer's claim, the restaurant manager measures the amount of liquid in each of 20 cups filled with the large setting and 25 cups filled with the medium setting. Let's let x bar sub L minus x bar sub M be the difference in the sample mean amount of liquid under the two settings. For this problem, let's start by describing the shape of the sampling distribution of the difference of these sample means, and talk about why we know the shape is what we say. Well, we know the sampling distribution of the difference of these sample means is going to be normal because we were told both population distributions are normal. To find the mean of the sampling distribution, all we need to do is subtract the means of the population distributions. So in other words, the mean of the difference of the sample means will be mu sub L minus mu sub N, 27 minus 17, or 10 ounces. To find the standard deviation of the sampling distribution, what we'll need to do is use our formula for the standard deviation, which involves taking the variance of each population divided by the sample size, adding them up, and then taking the square root. So in this case, since we were told the standard deviation for the large cups was 0.8 ounces, we square it to get the variance, divide by our sample size of 20, and then add to that 0.5 squared divided by 25. Standard deviation of the medium squared for the variance divided by 25. After adding all that up, we'll take the square root, and we find that the standard deviation of the sampling distribution is 0.205 ounces.
All right, so again, I want to take away the big ideas from this. They're talking about your shape and understanding to be approximately normal, you got to have the population as normal, and the central limit theorem has to be met for both samples. In which case, if the central limit theorem is not met, you need to draw a graph of the data to show that there is no strong skew or outliers. Understanding that our center for the difference in means is simply taking your mean value of the first sample minus the mean value of your second sample. Okay, and then understanding the standard deviation, understanding how to calculate the spread for the standard deviation of the difference in means, which is square root of your standard deviation of the first population squared divided by the first sample size, plus the standard deviation of the second population squared divided by the second sample size. So as long as you've got these guys all taken care of, these 3 points, approximately normal for your shape, your center and spread, should be all good. Hope you learned a little something today, and I'll see you next time.